Okay, so we're doing a scatter plot, yeah? And when we did our scatter plot, we created this 90 at 13, 91 at 26, 92 at 29, 93 at 27, 94 at 23, 95 at 39, and 96 at 41, right? And when we look at that, we have some kind of linear pattern. It's almost going like this, right? So it almost goes like this at one point, but it also kind of goes like this, right?
Yeah.
So with the two of those, in order to kind of balance each other out, you could end up, you want to have half below, half above, right? So we got 1, 2, 3, 4 below and 3 above. This is not a bad line, right? It works. I would also accept a line that looked like this, you know, maybe a little bit more down, right? Does that make sense? So that we have this one above and this one above and this one above and that one above and these below, right? I mean, either one of those would work, okay? Now, since there's multiple lines that could work, what do you think is the validity of that or the correlation? Is it linear, right? And how linear do you think it is? So in other words, was there only one possible line? Or did it seem like there was multiple possible lines, right? So that makes it so that it's almost kind of a thick line. Now it still has a linear relationship, right? But it's not like, it's not a 0.9, right? Now is this positive or negative? And they both seem to be positive, right? Positive slopes. So it's a positive correlation, right? But I would not call this a 0.9. I would call this somewhere around a 0.7. If you said a 0.75, I'm good with that. It isn't so far as a 0.6, you know? If you said anywhere between a 0.7 and a 0.8, I would have to accept that. So, I don't think 0.65 would be a little too far, you know, because as we get down to a 0.5, it becomes very little correlation, okay? So, at 0.5 and below, you get almost no correlation. Does that make sense? And there's still some correlation going on here. So that's what I would think anywhere between 0.7 to 0.8. And I'm good with anything in there. Okay? Alright, so that's an estimate. That's an estimated R value. Both of them are positive. Right? But now we got to figure out a line, right? A line. So, how would we figure out a line? And we would start to look at whatever line you want to look at. If you're going to look at the red one, then we're going to take a look at where it crosses, right? What is our slope? That's what's really important here. Okay? Okay? And so where does it cross? It looks like it's crossing right here. Ooh, right here. So at 1 and 20, right? So at 1 and 20 and at 6 and 40. Okay? So those would be my 2 points that I would use, right? And then we'd use it to find the slope, right? So y is on top, right? And then smack it. And so that'd be negative 20 over negative 5, right?
Yes.
And negative 5 goes into negative 20 4 times. So that means my slope is equal to 4 over 1, right? Now I use one of those points, I don't care which one. How about the 1 and 20? And I plug it in. Y equals mx plus b. Y is 20, m is 4, x is 1 plus b. So 4 times 1 is what? 4. So 20 equals 4 plus b. Minus 4 is 16 equals b. So it crosses at 16. Let's take a look. Oh, look at that. That's really close to crossing at 16. That's showing us at 15. So 16 is a solid number, right? So my equation to the line would be y is equal to 4x plus 16. And that's the equation for that line. Bam. So, the equation of the line, the correlation, it is positive, and it's between a 0.7 and a 0.9 for the R value. Okay? Questions?
No.
Sweet. No? Okay.
Is that 16?
That one actually turned out really well for